All right, let's get started. So welcome to the Crimson CDS session for 2022. I thought I'd start by giving a very brief overview of where we are with Quincy and a few thoughts on what our priorities should be for Reef. So on that note, major focus of the last year has been on stability and deployment stuff. Thanks to Radic, Crimson now has support in both Rook and Ceph ADM for deployment. We have an initial stab at a Crimson Rados Teuthology suite. It's even got a limited selection of the thrashing failure injection and all those good tests that we've come to know and love with Teuthology. And we've done a lot of work on stabilizing the bugs uncovered with that initial Teuthology testing. In particular, lots of refinements to the way op ordering works and improvements to the watch notify API. Sean May also did a bunch of work improving BlueStore's support in Crimson to the point where it works fairly well now. We've gained, moving on to C-Store, which is where a lot of development happened last year. We've got a new metrics framework and set of metrics so we can better understand how C-Store is behaving. This is going to be really important going forward as we improve, or as C-Store becomes more feature complete and we start focusing more on performance. So we've got metrics for the cache transaction conflict rate, a bunch of stuff in the LBA tree to help us understand the LBA allocation behavior, etc. It's already proved very useful in tracking down transaction conflict allocation problems due to incorrect hinting. A lot more work done with C-Store internals. There were rewrites to simplify and improve the LBA tree, generally speaking. Joyhan added support for placing extents in non-journal segments, as well as internal refactoring to support multiple devices. The conflict detection machinery got rewritten to use interruptible future. We added initial ZNS support. There's a ZNS segment manager that has been tested on an actual ZNS device, so that's good. And we have some Should I put a bunch of work into going down the list of Rados API test coverage that we didn't have yet. On the performance side, C-Store saw some improvements to LBA hinting and journal coalescing, both of which improved performance. Oop. Funky. There we go. So this brings us to our sort of our top line summary for Crimson in Quincy, which is that Crimson OSD in Quincy should support testing of RBD workloads without snapshots on Crimson OSD in a single reactor configuration with BlueStore, CyanStore, or C-Store backends, deployed with Rook or Ceph ADM. I think this is a fairly decent initial milestone, though I fully expect there'll be quite a lot of bug fixing along the way. But this will let us start evaluating Crimson in a somewhat more real situation. So moving on to Reef, the biggest things I see in Reef for Crimson as a whole are multi-core snapshots and scrub. Scrub is particularly important because we won't really be able to be confident in any other components without scrub working. Snapshots are a fairly core feature that Baton's going to be working on that should help us fill out the RBD use case. And multi-core is going to be critical for just being able to make use of modern hardware on a basic level. Single core was useful for a prototype, but that needs to be addressed for Reef. For C-Store, there's a ton that we'll be working on, but I think they mostly fall into a couple of big buckets. Further improvements to multi-device and tiering, particularly with respect to garbage collection. Support for fast NVMe devices via the random block manager. And once again, multi-core. And I think we'll sort of cheese this initially by simply running multiple C-Store instances against static disk partitions. This will give us a performance baseline that we can use to evaluate the changes to the metadata structures. We'll need to do this in a more clever way. So that brings us to what I think is the first sort of discussion point I wanted to get into today. I know, Yingzhen, you had added something to the schedule for to discuss GC strategy, so we'll get to that next. But before we get to there, I've been working more on Crimson in the last 2 months rather than C-Store. And I think it's important that we regularize the way logging works so that it behaves the same as it does in Classic. There are sort of three specific areas where there seem to be some disconnects. We don't respect the debug underscore config options from Classic, and I think we should. We've trained users and support and a lot of people to use debug OSD and debug MS to control the output levels when trying to understand what's going on. So I think we need to match some of the more common configs there, including the numerical values, although they'll map back onto debug, trace, and error in Crimson, of course. The other piece is that PG log messages in Classic have a macro, the dout macro, that ensures that the log lines are always formatted the same way. This is useful for a bunch of reasons, including because it allows you to very easily grab out all of the log lines for a specific PG. So I think we want, if anyone wants to sort of volunteer to go and do that auditing, that would be excellent. And finally, vstart and Toothology log to different files in Crimson than they do in Classic. We log to osd.0.standardout instead of osd.0.log, and there are a few other differences. And I think we want to eliminate that difference as well. These seem like minor things, but as the wider community starts to interact with Crimson, we're really going to want to make sure that everyone's on the same page with debugging, especially when the differences from Classic aren't actually that important. The other piece is that now that we're going to have a release where Crimson kind of works, we're going to want to make sure that it continues working, which means I think we need to select a Toothology test to start with. That is our gating test for all PRs. So that from now on, when we merge any PR into Crimson, we run this Toothology suite consisting of, at first, a single test, and start expanding that test suite as we get better reliability. So with that, I open it up to comments, questions, reactions. For what it's worth, I created some tickets in the Trello board. Can you guys hear me?
Yes.
Oh, good. Okay.
A question on the debugging subsystem.
Yes.
Do we want? I believe we still want to stick to the sisters logging infrastructure. Is that correct?
Oh, we're not changing the logging infrastructure. What we want to do is match the command line options.
Okay.
Yeah.
Okay.
We've trained people to, like, just to name two common examples, debug ms equals 1 prints out all the messages that get sent, right?
Sure.
That's
And
my favorite my favorite debug mechanism ever. And not only should we support debug ms equals 1, should turn that on in Crimson, it should have the same format. Every character should be identical, so that any grepping is as close as possible to Classic, unless there's a good reason to change it.
Okay, I see. Because there are some fundamental differences between the logging infrastructure in Classical and in Sister. Even the number of debugging the number of verbosity levels in Sister. There are in Classical we have at least 20, even more. In the Sister, there are few.
Yep. So I think there's a pretty simple solution to that. Debug ms equal, or debug whatever equals 1 gets us error. And it'll have a special case for messenger because equals 10 or 20 would be equal to debug, and 30 would be trace. That's the convention we've typically used in the OSD anyway. It's very unusual that we create dout messages that aren't at 1, 20, or 30. 5 sometimes. But in other words, I think we can set thresholds that just map to error, debug, or trace.
Yeah, I think I have already defined some log, which log level will record which information in the messenger. So I think we can start with that.
Yeah, the only missing piece, my only request is that debug ms equals 1 should be identical to classic. Specifically the log line that prints sending and receiving of messages. Since we've trained people to use that one.
Yeah, makes sense.
Trying to find the pad so I can take notes. These are also pretty good onboarding exercises for anyone who's relatively new to the code base. So I'll just put that out there.
Hi, Sam. This is Guifeng. So I have one question. So for the Crimson design, do we have any consideration to cover the QLC case? I know from the early design, we can see the consideration for the DNS, but how about QLC, which maybe similar, but still have some difference if compared to the NS.
You're saying QLC, as in
Yes.
more dense than TLC. My strategy for that is that it's either fast enough to be treated as a random block manager or slow enough to be treated as a segment manager. So it will fall into the same bucket as ZNS, but we can have different backends so that it speaks a more appropriate command set. But we'll still write to it in a sequential way. Does that make sense?
Yeah, for QLC sequential write perform good, but for random it perform very bad. Yeah. Okay.
Yeah. So the strategy, I think, is that the interface is different, but the write pattern is identical to ZNS. Is that fair to, or the desired write pattern, I should say. Is that fair?
Yeah, similar. Yeah, thanks. Yeah, so another question. So if we, if some customer want to have some try on Crimson, so as of today, what is our best suggestion? If some customer want to do some POC on Crimson to understand the performance difference, that how they can get. So months before we ever see some share from Mark, it's Mark Nielsen from Red Hat team to share some performance benchmark, but with some kind of hack to get that result. So yeah, so the question is actually if some customer want to have early try on Crimson to compare what they can get. So as of the latest stability and as of the latest code base, what is your suggestion?
Well, like I said, Quincy should support testing RBD on Crimson. It won't be particularly stable. That will improve over the course of this year. But you should, I would suggest that if you have customers that want to try it, you work out or you do some testing yourself and help us work through whatever bugs show up in that environment, and then give them the instructions. Does that make sense? In other words, you should be able to deploy it. Ceph ADM and Rook have the ability to deploy it on Quincy. It won't be stable, and they should not count on it to keep data. Does that make sense?
Yeah, got it. Thank you.
It should work, mostly. Long enough to do benchmarking, probably.
Yeah.
Hopefully, we'll be more stable as we go through this year, which is a different topic I forgot to bring up, actually. Is that everything on that bit?
Yeah. Yeah, so, I asked this before we did get, several messages from the customer willing to, as the industry is moving to the QLC instead of the TLC. So we did see more interest from the field to see how Crimson can actually help the transition from TLC to the QLC. I mean,
For what it's worth, I expect C-Store's maturity to lag Crimson as a whole. So that'll be a little bit more difficult. But again, it should work now. It just won't be particularly stable. And it'll be changing rapidly this year. So any feedback you can get us during that time will be really helpful. Speaking of feedback during this year, there was another topic I meant to bring up. For classic OSD testing, the most recent release is usually fine for people. But for Crimson, we really don't want people testing the Quincy version come August. So I wanted to float the idea of doing a more frequent release, perhaps once a month or once a week. Some kind of an automatic build snapshot of just upstream main. What do people think of that? I propose that we do no testing on this whatsoever and no backports to them. They're just point-in-time snapshots that people in the community can download and run. It would give people a way to test Crimson more frequently than the yearly releases.
Yeah, this sounds good. If we can have some LKG, that's no good image, and with some instructions, so we can have more, have more interactions with the customers who are willing to move from Blue Store to the to the Crimson stack.
Yeah, that would be good. You could also help us write up instructions and fix bugs too. That's another place new contributors could help. Anyway, so that's something I'm going to try to push for with the wider community. I do not think that we are the only, I don't know, Greg and Josh are here. I don't know if you guys have an opinion. But I feel like we're not the only component that would benefit from this. It might also serve as a forcing function to improve our release pipeline.
Yeah, and Sam, as you just shared, so for Reef, for this release, we can now our targeting is actually to get the RBD work with Crimson, right?
Well, that should work with Quincy, but it doesn't have snapshots. So we are going to continue refining and improving RBD and probably picking up support for RGW and CephFS in some capacity.
Yeah, got it. Thank you, Sam.
But for what it's worth, RBD has been our primary target because from a CPU per IOP point of view, RBD is the most demanding user for the most part. So that's been our focus.
Yeah.
Right. Any other comments about this part? If not, I'm inclined to hand it off to Yingzhen. Yingzhen, did you want to talk about your GC strategy?
Sure. Let me find the link. I paste the link here. So the general background is that for C star to store the extend to the disk, I think if I can share the screen. So for every extend written to a disk, it has the extend has character. That means it can be hot. That means it is a root extend or a logical LBA extend or node extend. They are metadata, so they tend to be hot, and they can be cold, like the object data block or OMAP leaf. And every extend written to a disk has an age that it can be calculated by the current time minus the last modification time. So every extend has character and age. So from the LFS design, so it might be better to group the extent of the same character and the similar ages together, because they tend, or we assume they will have a similar probability to become that. And from the paper, there is a cost benefit garbage collection policy that will be more effective if we can achieve that goal to place similar extents into the same segment for reclaim. So that comes to this design doc. So the goal is to make sure that the extent can always store the segment can always store the extent of the same character and similar ages. And there's two factors. The first one, the first fact is that we can already split hot and cold extents into a different group of segments. So it is just a configuration, and we can enable that so that hot and cold extents will be placed into different segments. And the second part is that I think we can further introduce the generation to segments so that the generation number n will mean that the containing extents in this segment are reclaimed by n times, so that it means that in a single segment it can store extents with the similar ages, because that similar right, I think it will imply that it has a similar age. So this is a picture that this, for example, that if we have 3 generations and 2 extent characters, so we will have 6 groups of segments. So that each group will contain the specific character of either hot or cold, or the generation 0 or 1 or 2, so that each segment will have similar characters to be rewritten or to be reclaimed. So is there any questions about this? So
yeah, 2 observations.
Mm-hmm.
So generation is essentially a very coarse age, right?
Yes, coarse level of age.
Right. So my other question is, if we have a generation 2 hot segment, isn't that kind of definitionally cold?
What do you mean by, could you repeat?
So a hot segment that makes it to generation 2 without being rewritten.
Mm-hmm.
I guess you could either think of that as a cold segment, or you could observe that the hot segments containing hot extents will tend to cycle faster. So I guess hot generations are smaller time slices. I guess that makes sense. Okay. Is there any point at which you demote an extent to a cold segment?
I think it will always promote from generation 0 to 2.
Sure, but what if it goes from hot generation 10 to cold generation 5?
Well, the current thinking is that the hot and cold are the characters of the type of the extent. So it may be more better named metadata or data. It is a logical character of the extent. It's not about the may not make sense to name it as hot or cold.
Yeah, I think that's where I'm getting confused. I interpreted this as we begin with a heuristic prediction as to whether we expect it to be frequently modified or not, and then we adjust later if we're wrong. But I guess this is more like 2 different garbage collection strategies, one for metadata, one for data. Is that a better summary?
It's not different strategies. They just placed in different segments, different groups. But the essential policy is the same. It's the cost benefit policy. Only calculates the age and the benefit.
I guess I'm not sure of the advantage of splitting it like this. It seems more like if we predict that metadata segments will be more frequently rewritten, they'll naturally end up grouped near generation 0.
Yeah, that's true. So for metadata, it might be less have less probability to become generation 1 and generation 2 before it is dead. So
I guess I'm saying
that's
that any extent that does make it to generation 2, I think we're wrong about. It should have been designated cold. That's what I'm worried about.
maybe not true, because there can be possibility that some portion of the O node will not be accessed
Yes, we think that's actually going to be
for a
likely.
very long
If you
time.
have multiple pools on the same OSD, then pools with PGs or PGs belonging to pools that aren't frequently written will have those
Mhm.
portions of the O-node tree really will be cold, like forever
Yeah,
on average.
yeah. So it
So
will
even though they're
be
metadata, they'll be low, they'll be infrequently mutated.
yeah.
I guess
So
I'm
they will be
suggesting that we
moved to
want,
generation 2.
well, I'm suggesting that we may want to treat this as a heuristic initial guess, but not treat them as separately otherwise. For instance, we could write
Mhm.
cold, like if our heuristic guesses that an extent is cold, we could just write it directly into generation 3.
Yeah, that's true. I think we can directly write code to larger
Right.
generations
So
if we want.
if we do that, we don't actually need to separate the generations for hot and cold. They become the same thing. Metadata segments will naturally group towards the lower number generations, and data segments that don't get frequently written will just fall off the end. In other words, I'm not sure the division is useful.
I think the current problem is that when we rewrite the extents, we tend to mix all the different segments with different age together. So if we only write extents of generation 1 into generation 2, so the generation 2 will have similar age. That's the goal is to isolate the different ages, the extents of different
The,
ages.
the goal is actually to group extents by when they're likely to be mutated in the future. Age is just a
Yeah.
good heuristic for that.
Yes. So it's a guess, but I think do you think the assumption that the old extent will be unlikely to be
I guess I'm saying that I
become
think
dead?
this division could be more compactly represented by simply starting cold extents at a later generation. It
But
eliminates this
mhm,
strict division between extent types, which gives the GC more freedom.
mhm.
I'm not sure, but I wanted to put that out as a suggestion, basically. I'm
I think that
skeptical
could
about this
be
hard division.
I think that could be flexible once we have this in place, so we can try different groups if we
That's
want
actually
to
true.
merge. Yeah.
Yeah, this
So
could be
it's
something that gets
just
written into a pluggable
mhm,
garbage collection strategy. That's true.
yeah, it's just one form of the groups. So the general
Yeah.
idea is to introduce the generation concept into the segment.
Do you think this would allow you to do away with tracking lifetimes explicitly?
Sorry, I'm not
So
quite
we
follow.
spend quite a bit of metadata overhead now tracking last modified times, like
Mm-hmm,
second granularity or something. This would allow us
mm-hmm.
to do away with that entirely, right?
Yeah, I think that will remove some requirement to track individual modified time.
And we wouldn't need to
Do
record
you
them
think
that
so?
way. Okay, yeah,
Yeah.
I like that. I like that change.
So, any other questions?
Juehan, what do you think about trading the very granular U time we're currently using for modification time for this more heuristic generation concept?
Yeah, I think the generation version is better.
Cool. We may want to retain the timestamps for a little while.
Mm-hmm.
Actually, I think we should retain at least a compile time flag to enable them, because after we've run a benchmark, it would be nice to be able to dump a histogram of the ages of the extents and all of the generations. That will be one way we can evaluate the behavior of this algorithm. I don't think it's something we'll want to run in production, but it'll be a useful piece of information.
Mm-hmm. Okay, I think that makes sense to me. So the further idea is that if we have the generations, then we can have multiple tiers of devices. The concept of tiers is that each tier will have a group of have one or more devices of the same type, so it will have the same backend and the implementations. And the higher tier generally will have larger disk size, lower cost, but lower performance. So if the generation will help us to place different data into different tiers, because the larger number of generation also means that the data will become more cold, and it doesn't require frequent accesses, so it can be placed into higher tiers. And because each tier have different characters of access patterns, so we can use different types of devices. So we can put tier 0 to have more performance and more expensive devices for this implementation, and put more and configure larger and less performant devices into second tier. And we can have different implementations, internal implementations between different tiers, and the interface will be as simple as just allow the write transactions to move data from one tier to another tier. So I think that's a general idea.
Yeah, and to the question earlier, that would be ZNS/HDD/QLC. That'll be QLC devices as well in that cleaning policy 2 group. Yeah. This looks great. This makes all kinds of sense to me.
So that's all. I think we can, if we want further discussions, we can start a thread.
Yeah, I think this is generally speaking, the way to go. I think this looks great.
Okay.